Hello, everyone. This is Elena, and I am your speaker for the next session. My session is a practical guide to natural language processing. So we are going to see all together a practical natural language processing pipeline. I'm so excited to be here and to speak for the Shaping the Future with Deep Learning online conference. I'm sorry. Okay. Okay. I'm sorry. Yeah. Just a couple of words to introduce myself. My name is Elena, and my path to natural language processing started with my graduation on mathematics. I started working in a computer science company, and when I realized that machine learning is the interests me the most, I attended a post-graduation master in data science and machine learning. At the moment, I am part of the Italian team of Bixby Samsung project. Bixby is the virtual assistant of Samsung. You can connect me on these platforms, so Gmail, LinkedIn, or Twitter. So let's start with a very short introduction to natural language processing. When I think about natural language processing, I think of it separate in two parts: the natural language, and the processing. Natural language is all languages that humans actually use to communicate each other, and processing refers to computer, so is how a computer, a machine, carries out the instruction, the information. So what is natural language processing is a range of computational techniques that allow machines or computers to understand, analyze, and manipulate the human language. It's kind of, I'm sorry, oh no. It's like computers go to school to learn to write, to speak, and to read in Italian language, or in English language, or in Chinese, or in Spanish. Okay. So nowadays there are a huge amount of beautiful tools and libraries about natural language processing, and absolutely the most used programming language is at the moment Python. So during the presentation I will refer to part of code and to our libraries, and all of this will be on Python language. So let's start to see a natural language processing pipeline. You can see a enrolled pipeline, okay, is a complete enrolled pipeline of natural language processing application. It's composed of a lot of steps, and we are going to detail on each step. So let's start with the very first thing you have to do in a natural language processing application. The very first thing you have to do is to define the problem and define the right domain for your problem. For example, if you want to create a healthcare chatbot, you shouldn't be using a dataset that comes from banking or financial custom care dialog chatbot, okay? Because the two applications belong to two different domains. And so when you will collect the data, the dataset, you collect the right dataset for the right domain, okay, for your problem. Why this is so important? Because from the dataset you will create the vocabulary. A vocabulary is a set of words that your model at the end of the pipeline will know. So if you choose the wrong dataset, you will create the wrong vocabulary. Okay, so it is extremely important to define the domain and collect the right corpus. Corpus is Latin, is a word used in natural language processing, and it means raw text data, okay? What about Python? Python offers two good scraping libraries that are Beautiful Soup and Scrapy. Let's move on to the second step. So now we have collected the right data, okay? And we can start to clean and pre-process this raw data, this corpus. So the goal of this step is to clean your data in order to extract as much useful information as possible, keep in mind, reducing variance of data. Why it's important to reduce invariance of data? Because at the end of this part of the pipeline, we have the most expressive vocabulary. If you remember what is the vocabulary in the previous slide, have the most expressive, rich vocabulary, keeping its size small. Why is it so important, the size of vocabulary? Well, we will understand at the end of this presentation. This is you can see a lot of steps. Not all are needed, necessary, or only tokenization is really mandatory of all of these steps. We will use, in particular, two libraries of Python, RE, that is the regular expression library, and NLTK. NLTK stands for Natural Language Toolkit, and it is a kind of Swiss Army knife, okay, for the natural language processing. It means that that NLTK is not terribly good to do anything, but it is full of good basic tools. Keep in mind that in this step, most of your time will be spent in this step in cleaning and pre-processing the text. So let's start with the first step. Two very common practices we usually do with the text is lowercasing the text and removing punctuation. Why it is important? Because, for example, if I don't lowercase the text, at the end I will have a data set in which Rome, written in these three different ways, will be three different words. But we know that Rome is only one word. So this is the reason why the lowercasing is so important. And the same situation for punctuation. If I don't remove the comma or I don't remove the exclamation mark, these three words will be different, and we don't like it very much. So we should ask ourselves if do punctuation or capital letters contribute to the meaning of the sentence in our natural language processing application. Because, for example, if my problem is to create a text generator, for example, with a text generation problem, the punctuation is extremely important, okay? We can use an LTK, we can use the library string. Here you can see a list of punctuation of the library string. But you be careful to. It's very important that you will be careful to remove the punctuation. For example, if you remove all of the punctuation and you will need later to recognize an email, maybe you can encounter some problems, because if you remove the hat, will be hard to recognize the email. Or if you're interested in the currencies and you remove the dollar symbol, maybe exactly you will encounter some kind of problems. Another very common practice is remove the stop words. A stop word is the opposite of keyword. Keyword is a word that is full of information. A stop word is a commonly occurring word such as the, A is it. Inside NLTK, we can see a list of English stop words, and you can see that in it is for example, the articles, the modal verbs, the pronoun, the personal pronouns, and for example, the negation, okay, no, not, nor. Another time, you have to ask yourself if stop words are important for your application, because, for example, if you want to create a topic extraction, stop words are not very important, so you can remove it or remove them. But if you want to create a sentiment analysis, a sentiment analyzer, well, if you remove the negation, maybe maybe it could be a problem. Well, we now see the tokenization. Tokenization is the really unique step that is mandatory in all of the pre-processing steps. Tokenization is the process of splitting your text, your sentence, yes, your text, into a list of tokens. Token is the smallest unit that will be processed by inside your machine learning model. So, for example, if you tokenize, the most used or the simpler tokenization method is to split the text when you encounter white space. So if you choose this kind of tokenization, for example, lucky with the exclamation point will be a token, okay, and will be different from the token lucky without the exclamation point. So have a look to keep in mind to be careful when you choose your tokenization method. There are a lot of libraries that perform tokenization, for example, NLTK, of course, Spacy, Keras. Spacy is an open source software library for advanced NLP in Python, and we will see better later. A hint I'd like to do is look at time. Tokenization is a real bottleneck of natural language processing. Once we have tokenized, once we have done with the tokenization step, we can perform a stemming or lemmatization step. Both stemming and lemmatization has the goal to reduce the variations of the same words to the stem in the case of stemming and to the root word in the case of lemmatizing. You can see better in this example. I download the WordNet lemmatizer and the Porter stemmer from NLTK. If my sentence is yesterday I studied the mouse series, okay, is a no-sense sentence, but okay is exemplative. And for example, if I perform a stemming, I remove all the prefixes of a word. So, for example, mouse, I remove the final E. Or, for example, studied, I remove the ED prefix. So I reduce the word study, and I can simply see that these words are not real words in the language. Stemming is a quite aggressive step. Lemmatizing is less aggressive. And I move my word to the root word. So, for example, the plural in the singular, and the studied, yes, I move to the infinite form of the verb. At the end, last but not least, okay, yes, there is the normalization step. Is here when you have to when you have to take a deep look at the corpus, because is now that you normalize your text. For example, it's now that you handle with numbers, or when you recognize a recurring typo, you can correct them or correct it, or maybe here you can explode an abbreviation. So, for example, for square, street, or etc. Here you can clean or convert smileys. And here you can anonymize data. So, for example, you can write a regex for recognize an email. Okay. When you recognize an email or a mobile phone, so and once you have matched it, you can anonymize it. Okay, so this is the text preprocessing and cleaning step. If you want and if you need it, you can you can perform some text enrichment steps. For example, the post tagging. What is post tagging? Is the tag of each word as its part of speech role inside the sentence. So, for example, if I'm interested in knowing that made is a verb, is tagged as verb, or for example that the is tagged as an article, or to recognize where is a word is a noun or a verb or an adjective. Post tagging is really useful for word disambiguation, because if I have these two sentences, she saw a bear, and your effort will bear fruit, maybe for me it will be useful to know that this bear is a noun and this bear is a verb. Okay, Spacy is the most used library for this kind of operation, both for post tagging and for NER. This is an example of Spacy using for post tagging this sentence. Can you please buy me an Arizona iced tea? Well, we can see that with Spacy you can perform in one moment the lemmatization and post tagging. So, for example, exactly, Spacy recognize that buy is a verb, okay, that you is a pronoun, can is verb, etc., etc. And with lemmatization, Spacy split he, its in it pronoun and as the verb, and the lemma of as is the verb be. Identity recognition is another kind of information extraction action you can do on your text, and you recognize when and where a word is an entity. What is an entity? The most common entity is person, organization, and event. And surely you can understand better with this example. So if my text is this, London is the capital and most populous city of England, and I perform a NER action with Spacy, we obtain this. So Spacy recognizes that London is a geopolitical entity, so this is a geographic entity. Bill is a person, and Apple is an organization, is not a fruit apple. So just to make a quick recap of the preprocessing phase. So we collect the raw data, we make the preprocessing action, and we obtain a list of tokens. From this list, we create the vocabulary. So the first thing we have to do when creating a vocabulary is decide the vocabulary size. The second thing to do is counting how many times the token, every token appear inside our list. We order them, the tokens, from the most frequent to least frequent, and then we take from this list only the first the first V tokens. Text preprocessing can be a time-consuming task and full of trade-off. Why trade-off? because we are obviously losing information. So it is important to understand what kind of information I can tolerate to use. There is a needed intermediate step before going to the machine learning algorithm, because right now I have text and I know that computers can't process text. Okay, so we need a way to convert the text into a vector of numbers. And now the real problem is how can I encode the meaning of a word inside numerical vectors. In the traditional NLP, and with traditional I mean before 2013, words were represented by one hot vectors. One hot vectors are sparse vectors that are composed of mostly zeros, except of one cell with one. So, for example, these are the one hot vectors of hotel and motel. The vector dimension is the same of the vocabulary dimension, because the one element is corresponding the one element corresponds to the position of hotel word inside the vocabulary. So this zero is because maybe first word of the vocabulary is dog. So this is zero for the dog. This is zero for maybe the word cat or another word. One is when inside the vocabulary we found the hotel word, and the same thing for motor. The major problem of this kind of thing is that these vectors are also orthogonal, so it's difficult to define a natural notion of similarity of one vectors. The solution of this problem is a change of paradigm. And the changing is to see in a different way the definition, the meaning of a word. So what is the meaning of a word? A word's meaning is given by the words that frequently appear close by. So I define a context. The context is the set of words that appear nearby. And what I mean that the meaning of the word banking is be represented by all the words that frequently appear nearby the word banking. We will build a dense vector, and we refer to them with the word embeddings. So we will build a dense vector, and the dimension of this dense vector is an hyperparameter. So we choose, we decide what is the vector dimension, but surely is much smaller than the vocabulary dimension. What happened in 2013? In 2013, Thomas Mikola from Google present Word2Vec. Word2Vec realized all what we have just said in the previous slide, okay? So Word2Vec is a new model for word embedding, and it is a shallow deep learning model. Okay. Further research has built on top of Word2Vec, so for example, Globe and PastX. The major library of Python used to create word embedding is Gensim. Just to give you an idea on how this Word2Vec well. For example, if I wanted to see the most similar word or vectors on the vector, the word embedding of Obama, the most similar vector is Barack, okay? Or for example, if I want to know if man stands to king, then woman stands to queen. Or for example, if Japan stands for Japanese, Australia stands for Australian. Okay, we are talking about vectors, not words, but the way into Word2Vec capture the semantic definition, the semantic meanings of the word is extraordinary. Okay, I'm sorry. So from Gensim, we can download our pre-trained word embeddings, or we can create them, or we can create a new word embedding based on our dataset. Just a few seconds to name the second revolution we are going to live in this moment with natural language processing. If word2vec was the first revolution, now with Elmo and all BERT-based model, we have the second great word NLP revolution. Revolution on word embedding, and we are now we are now referred to contextualized embedding. Contextualized embedding, that the embedding depends on the meaning of the word inside the sentence. Okay, so now we are finished. We can apply our machine learning algorithms. Every or almost all natural language processing task is a classification task. So now we can answer to the question why it's important to keep the vocabulary size small, because if we are in a classification task in our output layer, we have to do a softmax action, okay, to select the most likely word in that situation, and making softmax distribution on all the vocabulary, it would be extremely computational heavy. When we are talking about natural language processing in general, we talk about recurrent neural network-based models, okay? There are a few examples of also an application of convolutional neural network on natural language processing, and most popular right now, most popular models for natural language processing right now is based on the attention mechanism. Thank you for your attention.
So for sure, there are a lot of questions for you. Are you ready?
Okay. Yeah.
First one.
It's a good thing to have a lot of questions.
Yeah, we have just 5 minutes. So there are any rule for decide the best size for vocabulary and embeddings?
Okay, it is a very, very important point of the natural language processing analysis step. Okay, what about the vocabulary? About the size of the vocabulary, we have to make a distinction between two cases, and the distinction depends on the answer to a question. The question is how many languages you have to handle with your natural language processing application. Because, for example, if you have to manage only one language, for example, Italian language, it is a common practice to take a vocabulary size between 20,000 and 30,000 tokens, for example, is a good choice. But on the other end, if you have to create a cross-lingual, multilingual application, you, of course, need bigger vocabulary size. For example, just to take the example of the Hugging Face pre-trained model of BERT, the multilingual pre-trained model of BERT of Hugging Face that handles 100 of languages, it has a 100,000 vocabulary size, for example, that contains 100 languages. So it depends. For word embedding size, it depends mainly on your computational power, because of course, the bigger the size of word embedding is, the best the performances will be. So, but of course, we don't always have the opportunity to have a lot of computational power. So it depends. The smallest dimension of word embedding I have ever seen is about 50, if I well remember. But you can select a word vector dimension between 200 and 500 is commonly is a common practice.
Okay, thank you. We have more or less 2 minutes. So other question is, can NLP be applied also in voice recognition?
Okay, yes. When we talk about natural language processing, we usually talk about text data, so written data. If we are talking about audio recognition, we are talking about audio engineering. Okay, so you simply take all the pipeline I showed you just few minutes ago, and you have to put at the beginning the translation from the waveform of the data, because with an audio application we have the waveform, okay, of the audio. So you have to translate the audio into the text. There are a lot of models about acoustic models, okay? And once you have the written text, you can start to manage the pipeline of NLP to normalize it, and what can you do? Yeah.
Okay. I think we have just 1 minute for the last question. So stay briefly. So which tool you suggest to perform text normalization? There is any way to visualize sentence in terms of data exploration?
Okay. The only way to correctly visualize your data is really open them. So there is no specific tool for normalize. There is all of the libraries of the method of an NLTK library, Python library, for example. But for normalizing, you may can select some particular kind of raw data or incorrect data, and visualize them, how they change when you perform their normalization. So there is no specific tool. You have to open the data and read them, and it is very important to monitor monitor every step you perform on your data. Is it
okay? Thank you, Elena. So we reached the end of the answer question.